Okay, so the next question that you guys struggled with a bit more was this one. This is about a geometric sequence. And we know a geometric sequence is one where you don't add the same amount each time, you multiply by the same amount each time. Okay, so this is one that I've just drawn here. Each time we're going to multiply by 3. Okay, so this will have the form 3n. Okay, now if I actually write out what the terms would be for 3n, if that was my nth term, well, that would look like 3 to the power 1, which is 3, 3 to the power 2, which is 9, 3 to the power 3, which is 27, 3 to the power 4, which is 81. Now, what I was aiming for was 4. What I was aiming for was 12. So in this case, I need to make a little correction, and it's going to be a multiplicative correction because we're dealing with multiplying each time. So each time I will multiply by 4 over 3, okay? Because 3 times 4 over 3 gives me 4. So my final answer would be un equals 4 over 3 times 3 to the n. Now, what you can do if you want, and sometimes the question might ask for it to be in a certain form, is you can rewrite this as, we could write that as, if we wanted, as 4 multiplied by 1 over 3 times 3 to the n. And we know 1 over 3 from our work that we did on powers, we can rewrite as 4 times 3 to the minus 1, okay? It's the reciprocal, times 3 to the n. They've got the same base, so if we want, our final answer could be written as 4 brackets, we wouldn't even need the brackets written, yeah we would, 3 to the n minus 1. Okay, so just two different ways of writing the same thing there. Okay, now this sequence that we've been given, sorry, I'll continue on a different sheet. So just to go back here, it says the first term of a geometric sequence is 3, and the common ratio, so that means what we're multiplying by each time, is 1 over 4. Find an expression for the nth term. So I'm just going to work on that up here. So I'm going to start with this. Okay, it's 1 over 4, so it's going to be 1 over 4 to the power n. It's going to have that form, and then we're going to need to make a correction. Now, if I do 1 over 4 to the power n, if I kind of wrote out that sequence with n equals 1, 2, 3, 4, so if I try that out and then see what correction I need to make, that would give me 1 over 4, and then it would be 1 over 16, and then it would be 1 over 64, and it would be 1 over 256, okay? Now, it says that the first term of the sequence, if I go back to the question, is 3, okay? So I need to think, what correction do I need to make to go from there down to here, okay? Well, 1 over 4 multiplied by what gives me 3? Well, 1 over 4 multiplied by 12 gives me 3, okay? So my final answer would be, and I'll just write that over here, we want the nth term, it would be 12 multiplied by 1 over 4 to the power n. Now, again, we can write that with that n minus 1 form, like I did in the little example I showed you a minute ago, by spotting that we can rewrite this thing as 3 multiplied by 4, okay, and I've chosen 4 because we've got a 4 there, to the multiplied by 1 over 4n. I can rewrite this thing as 3 multiplied by 1 over 4 to the minus 1. 1 over 4 to the minus 1 is 4, multiplied by 1 over 4 to the n. We've got the same base, the same big number, so I can add the powers, which will give me 3 over 1 over 4 to the n minus 1. Okay. Note that both are the same. Sometimes you might be asked to give it in a certain form if it was a, you know, if it's a longer question or a slightly higher number of marks for the question, you might be asked to write it in this n-1 form. But on Dr. Frost Maths, where you've been completing it, it will have accepted either. Okay, and people who wrote that for their answer, it will have said it's correct, as will people who have written it in that way. Okay, final one, let me just get it here. It's about quadratic sequences. So this is a different type of sequence again. Okay, 2, 14, 36, 68 are the first four terms in a quadratic sequence. Okay, the nth term of the sequence looks like this thing, so it's pn squared plus qn. Find the values of p and q. So it's essentially saying find the nth term. Okay, the nth term is going to look like that. Find the nth term. Now, I've just written it out already here. Key thing with a quadratic sequence. Okay, so it goes what we call the first difference. Okay, so adding 12. Adding 22, we're adding 32. The first difference changes, but the second difference, okay, to go between the terms, the second difference is the same, okay? So we're going to add 10 each time. If we wanted to get to the next one, okay, we would add 42 because we're going to add 10. So quadratic sequences, you've got a bit of an awareness of this already. To find, we know it's going to have an n squared in it, okay, and to find the coefficient of n squared, the number in front of n squared, or in this case, p, okay, we half the second difference, okay, we half the second difference, so it's going to be 5n squared because our second difference is 10. So we've already found our value of p, okay. Incidentally, if it was a cubic sequence, which you don't look at it at GCSE, if it was a cubic sequence, you divide it by 6. Okay, so let's just write out what a sequence, what 5n squared would actually look like as a sequence. So we're aiming for 2, 14, I'll just draw a line under there just to keep it tidy. 2, 14, 36, 68. Let's see what we actually get. Well, 1 squared is 1 multiplied by 5, but that's going to be 5, okay? 2 squared is 4, multiplied that by 5, that's going to give me 20, okay? 3 squared, because it's the third term, 3 squared is going to be 9, multiply that by 5, that gives me 45. 4 squared is 16, multiply that by 5, that gives me 80, okay? So at the moment, 5n squared gives me this. I need to make a correction. Well, to go from there to there, I'm going to subtract 3. So right here, correction. So subtracted 3. From there to there, I've subtracted 6. From there to there, I've subtracted 9. And from there to there, I've subtracted 12. So the correction for the first one will be -3, the second one will be -6, the third one will be -9, fourth one will be -12. Notice with a quadratic sequence, our correction is going to be adding or subtracting. In our geometric sequence, our correction was multiplying. Okay, so we've got these numbers, -3, -6, -9, -12, okay? So that will actually form, these numbers themselves form a linear sequence, okay? If I just said find the linear sequence, find the nth term for this linear sequence, you just say, okay, well, we're going down by 3 each time, okay? So it's going to be -3n, and we're starting at -3 anyway, so the nth term of this sequence is -3n, okay? -3 times 1 gives me -3, -3 times 2 gives me -6, -3 times 3 gives me -9. Okay, so that's our correction. So to put it all together, if we have 5n squared, but then subtract 3n, because that's what we're doing in each case, that will take us to our answer. Okay, so the nth term for that quadratic sequence is 5n squared minus 3n. And let's just go back to the question, okay? It says the nth term of a sequence is pn squared plus qn. Find the values of p and q, right? So let's just make it really clear. We're going to say p is equal to 5 and q is equal to negative 3, because that was plus qn and it's minus 3. So make sure we get that right there.